Hello everyone. So in this video we are just starting public key crypto system, and the very first public key crypto system is RSA crypto system. So in this video we will be discussing about RSA crypto system. What are the outlines of RSA crypto system, how we can encrypt and decrypt using RSA crypto system. Then in next week upcoming videos we will be discussing about the examples of RSA crypto system. So this RSA crypto system is a public key crypto system. It is a public key crypto system. This is a public key crypto system. It is invented in 1977. It is invented in 1977 in MIT by three cryptologists, namely Rivest, Shamir, and Edelman. So on their name, like R from Rivest, S from Shamir, and A from Edelman, the crypto system is given the name RSA. So this is a public key crypto system. When we talk about public key crypto system, it means it will have two pair of keys. Every party in this system, whether it is sender or receiver, every party will have two pair of keys. So one is known as public key, which will be public to all, and another one will be known as private key. So this will be private to every party. Like for example, sender will have its own private key, receiver will have its own private key. So this public key is used for encryption, and the private key is used for decryption. So usually in public key crypto system, sometimes we maintain the public key directory also. Like this is, let's say this is a public key directory. So in this public key directory, everyone how many of there are senders and receivers, or everyone will put its own public key, like Alice, Bob, maybe XYZ, someone else. So everyone will have its own public key here. So only public key, not the private key. Private key they do not share their private key with anyone. Okay, so now let's say Bob want to send a message to Alice. So Bob needs Alice public key. Bob can receive Alice public key from this directory. Alice want to send some message to XYZ. Alice can check the XYZ public key from here. So this is known as public key crypto system, because we have two kinds of key, public and private. Public is for encryption, which is public, which you can send it to the insecure channel also, and private is for decryption. So every party has its own private key. So it should be we should choose private key, getting the private key should be, or calculating such that every party should choose private key such that getting or calculating the private key should be a computationally hard problem, so that no one can calculate the private key. So now let's say we have sender, or we have Alice and Bob, and let's say Alice want to send some message to Bob. Alice want to send some message to Bob. So what Alice will be needing? Alice will be needing Bob's public key. Alice will be needing Bob's public key, so that Alice can encrypt the message using Bob's public key. Okay, so here are, let's say Bob is having two pair of keys, so it means Bob need to generate its keys. So Bob need to generate its keys. So let's say Bob generate two keys, EB and DB. EB is for encryption and DB is for decryption. So it means EB is the public key. So what Bob will do? Bob will send its public key through the open channel, public channel or insecure channel to Alice, or Bob can keep its public key in this public key directory. Alice can receive that from here also. Now what Alice will be doing, let's say Alice want to send the message M. So what Alice will do, Alice will generate the ciphertext using Bob's public key EB M, and then Alice will send this to Bob. Now this ciphertext can be decrypted only with the help of encryption. Decryption will be done at the Bob's end, and the Bob's private key and public key has been chosen such that this decryption can be done at the Bob ends using its private key. No one else can decrypt. So this should be equal to M. So Bob should select its public key and private key in such a manner that encryption can be done with the help of public key, and then decryption can be done with the help of private key. Also, this getting the private key should be a computationally hard problem, so that no one else can generate this private key. Now let's check about the RSA crypto system in full detail, how these keys are generated and what does it mean by generating the key. So this RSA crypto system, so first thing is the setup of RSA crypto system should be generated by Bob, because Bob has to send its public key to the Alice, then only Alice can encrypt the message. So we will check the Bob setup stage or Bob scheme, how Bob going to set up the scheme. So what the setup Bob will do, first thing Bob will select two large primes. So it should select two, and it should be large, two primes, and they should be large primes. So Bob should select two large prime, and let's say the prime are P and Q. Then next step is Bob will compute N, and this N will be equal to P and P into Q. And after that it is going to generate phi N. What is this phi N? It is Euler-Toccian function or Euler-phi function. This we have already seen. This is Euler's Toccian function or Euler's phi function. So now it will generate, and because P and Q are prime, so phi N is going to be P minus 1 into Q minus 1. Now next step, choose an integer E. Choose an integer E such that GCD greatest common divisor of E comma phi N should be equal to 1. Or you can say that E comma phi N should be equal to relatively prime. Why we need this? Because during the decryption we need to, at the decryption time we will be needing inverse of E. So inverse of this phi N. So we will choose it like this. Now the last one is find a D, just for the inverse, find D such that E dot D should be congruent to 1 mod phi N. So this is the setup which will be generated at the Bob's end, because Bob has to send its public key to the Alice. Now what is the key? Key is a 5 tuple. What is the key? Key is a 5 tuple. We have two types of key, and this key is a 5 tuple. Let's say K is key. Key is a 5 tuple N comma P comma Q comma E comma D. So these 5 things are key such that ED should be congruent to 1 mod phi N. So then key is a 5 tuple, and how this work? N comma E is public key of Bob. N comma E is public key of Bob. And usually we represent it with EB. And P comma Q comma D are private key of Bob. Private key of Bob, and usually we represent it with DB. So this is public key and this is private key, and what is N, E, P, Q and D, we have discussed it here. Now we will check about the encryption and decryption. So let's say Alice and Bob, Alice want to send some message to Bob. So Bob has generated its EB and DB, it means private and public key, Bob sent this EB to Alice, and using this EB, what is this EB? EB is equal to n comma E. So n comma E is public. Now the Alice want to generate the ciphertext. So let's say M is plain text and M belongs to Zn. This M should be selected like such that GCD of M and N should be equal to 1. This we will discuss while we will be discussing the decryption, that why we need it 1. So it means the plain text is encrypted in block. Every time plain text is encrypted in blocks, with each block having a binary value less than some number n. We should select the block having a this M is a block of plain text, and this block having a binary value less than some number n. So usually the block size must be or equal to log n base 2 plus 1. So this we will be discussing that why we need this while at the time of decryption. Now Alice will encrypt the message and send the ciphertext to Bob. Now what is the encryption, how it is going to encrypt, and what is the decryption, how it is going to decrypt. So RSA encryption is, for example, RSA encryption. So RSA encryption says the ciphertext C is equal to encryption. We will generate with an encryption key or public key of Bob, and message is M. It will be M to the power E mod n. M to the power E mod n, because EB consists of n comma E. So this is RSA encryption, M to the power E mod n. Similarly, what is RSA decryption? RSA decryption says we need to generate M, because it is decryption, with the help of ciphertext and the private key DB C. So it means C to the power DB mod n. C to the power DB mod n. Now we need to check that what is this C to the power E DB and how it gives us M. What is this C to the power DB mod n and how it gives us M. So it means what we want to do, we need to verify this decryption process. We need to verify the decryption process of RSA algorithm. So for example, let's say we have C to the power DB mod n. So what is this DB? DB is the private key of Bob, and what is the private key of Bob? It is D. Okay, so it means this is C to the power D mod n. It is C to the power D mod n. Now we are going to put the value of this C here. So it means it is M to the power E to the power D mod n, and here it is M to the power E to the power D mod n. We can write M to the power ED mod n. And when we select Euler-Tochet function or Euler-Phi function, what is this ED? ED is equal to 1 mod phi n. So this ED is congruent to 1 mod phi n. And what is this phi n? Phi n is the Euler-Phi function or Euler-Tochet function. It means number of integer less than n, and it has number of integer which are less than n or co-prime to n. So we can write ED is equal to k of phi n plus 1, where k is any integer. So we can put this value of ED here. So here it comes out to be M to the power k of phi n plus 1 mod n. So we can write it like this: M to the power phi n to the power k m mod n. Okay, now what we have to see? We have to see that how this number comes to be m. So this we can write M to the power phi n mod n mod n to the power k and m mod n. So now what we need to check? We need to check that how it comes to be this one, how it comes to be 1, or how it complete number comes to be m. So this we can see m to the power phi n, this m to the power phi n mod n to the power k. This is 1 according to Euler's theorem. We have already checked about the Euler's theorem. Euler's theorem says that let m and n be two integers. Let m comma n, we have already discussed Euler theorem, m comma n be two integers such that GCD of m comma n is 1. If GCD of m comma n is equal to 1, then m of phi n is congruent to 1 mod n. It's congruent to 1 mod n. So this comes out, this complete number comes out to be 1. When it comes out to be 1, it becomes m mod n. And now you understand then that when we say that we are going to choose m such that GCD of m comma n is equal to 1, so it means now it comes out to be m. So this is how the decryption is done in RSA algorithm. So this is decryption and encryption. This is all about RSA, how we generate the public or private keys, how we generate decryption, encryption. This will be like things will be more clear once we will be doing some example. So in upcoming videos we will be doing it with the help of example. So let's take a quick revision. So RSA crypto system is a public key crypto system. It is invented in 1977 in MIT by the cryptographers Rivest, Shamir and Edelman. And on the name of the we take first alphabet of every like researcher and put the name like RSA crypto system. Because this is a public key crypto system, it means it is having two keys. One is private key and one is known as public key, and another one is known as private key. So public key is known as public key is used for encryption and private key is used for decryption. Then we have a public key directory. So every person involved in the crypto system can put its public key to this directory, and whosoever is needed, because this is public key, they can collect it. So Alice and Bob, Alice can encrypt using the Bob's. The thing is, Bob is having, everyone is having its own private key and public key. Now for example, Alice want to send a message to Bob, so Alice will encrypt it using Bob's public key, and Bob will decrypt it using its own private key. If Bob want to send a message to Alice, Bob will encrypt it using Alice's public key, and Alice will decrypt it using its own private key. Okay. So this is the like setup for RSA crypto system. So like for example, Alice want to send, so Bob need to generate its public key. So this is the setup by Bob. He will select two large primes P and Q. Why we are saying about two large prime numbers? Because we say that generating the private key or calculating the private key should be the computationally hard problem. So whenever we say that it is large prime, it is very difficult to generate. So select two large prime P and Q. Compute n is equal to p into q, then compute phi n also. Phi n is the Euler quotient function. This you know how you can compute, because the p and q are prime, so p minus 1 q minus 1 are Euler quotient function. Then choose an integer c such that GCD, choose an integer e such that GCD of e comma phi n is 1. So because during decryption we need to generate its inverse. Okay. Now this is the key is 5 tuple where n and e are public key, p, q and d are private key of Bob. So now let's this is the setup. Here one more thing, this m should belongs to Zn, and GCD of m and n should be 1, so that we can decrypt it. So RSA crypto system, this ciphertext encryption should be m to the power e mod n, and decryption should be c to the power db mod n. And how this decryption works, this we have discussed it here, that how this decryption comes to. So there are some issues. So there are two issues. First one is how to calculate large number, because we say that there will be large prime. So first issue is how to calculate large numbers. And second is we say that primes and those should be the large prime. Then how to get those primes? How to get primes? These two are most important issues in RSA, that how to get primes, because getting the large prime is not an easier task. How we can, like for example, I write 5 2 7 8 9 7 7 9 5 1. How we will confirm that this is a prime number? So this is again an issue with this RSA, because factorization should be hard for security. That is why we need to choose large prime. But if we choose large prime, then how we will confirm that this is a large prime number? Because 512 bits prime number, because there can be a 512 prime bits prime number, there can be 1024 bits prime number. Is there any algorithm to get large prime? No, there is no defined algorithm to get large prime. So we need primality testing with many different ways. So primality testing is another topic of discussion which we are going to discuss. So in upcoming videos we will take some example of RSA and then we will move to the primality testing. Thank you.